Hello explorers and welcome to another video. Today we're gonna do Advent of Code Day 6. And this day we are talking about the distance between two entities, and in this case we are talking about planets and their orbits. So we have a planet that might orbit another planet, and then we have the center of mass, so that's the middle of the universe. This is called COM. And when we have this center of mass, everything will be going to the center of mass. Nothing is actually orbiting, or center mass is not orbiting anything else. So in this example down here, B is orbiting center of mass, C is orbiting B, and so on. So we can see that we get this kind of a graph down here. And our first task here is to figure out how many indirect and direct links there are between all of these planets. So for instance, in this case, we have a link between G and H. We have a link between G and H and B, and we have a link between H and COM, but we also have a link between G and B, G and COM, and B and COM. And for all these different possibilities, we actually have 42 different orbits that we can calculate, either direct or indirect. I'm not really sure how I would solve this problem. I could make a little bit of a graph and make a lot of arrows between them. I'm not sure if that will help me with the calculation though. But if I make a graph and that I know that this is 1, 2, 3, 4 from that, that means that it has... So this is a little bit of a interesting puzzle. So I will try to start coding here and get this example right. And I guess if I get that right, I probably will get the other input data right as well. So I see you in a bit when I've done some coding. And I'm back, and I have already calculated the number of orbits, and today's puzzle was a little bit interesting, and I'm a little bit afraid that the solution that I came up with might not be perfect for the next puzzle, but we'll see. We will handle that when we come to it. So first off, we have this little map here, so I will put a lot of planets in and I give them a string so I can easily find them again in this map. So I have a map of planets, and then I will read each line of this file, and I will split them up with the parentheses, the ending parentheses char. So that means that I will get planet 1, planet 2. So 2 planets here. And when I've split that up, so I will check if the planet pair that I get here will contain, if my planets list contains this planet. Otherwise, I will create a new planet in this list. And the same goes for planet 1. I will also create a new planet for that. And then I will take my planet 1. So this planet that is the planet that is the furthest away, so it will orbit something, and then I will add an orbit to that planet, and I will add the first planet to that, or to the second planet's orbits list. And when I've done that, the only thing I need to do is have a total and run through each planet and get the number of total orbits and print that out. And if we look at the planet here, we have a name, and I can get that name. I haven't used that yet. And then I will add orbits. So this has a set of orbits here. So add to those. I can get all the orbits. And total number of orbits is the size of all the orbits I have for this planet. And then I will go through each of the orbits and ask for the total number of orbits of those planets and sum that up and return. So this calculation was not that intricate, and I hope it works. Let's see. Let's go back to the page here, put it in, submit. Yes! You get a gold star. I get a gold star. Everybody gets a gold star. We solved this one too. So let's go over to part 2 of this one and see what they have done to make this a little bit harder to figure out. So I will read this one and get back to you when I have figured out what the actual problem is. And I'm back, and this is one that it might be a little bit harder. I hope that I can use very simple logic here. So what they want us to see, if we have us, you, and San, which is Santa, and we will need to see how many orbits jumps we need to do in order to get to the same orbit as Santa. So for instance, here I am, you, and I'm orbiting K, and I need to jump from K to J to E to D to I. So that's 1, 2, 3, 4. And then I will be at the same orbit as Santa. So this is a little bit interesting, and I will try to figure this one out so I can actually get 4 jumps, and then I will try it out with the large input that we had before. So when I've figured out the solution for this one, I'll get back to you. And we are back, and this problem was a little bit more challenging, and I didn't really figure out how to represent the actual structure in a good way, so I can actually count how many jumps there were between me and Santa. But I was thinking about it a bit, and this way of structuring all this with the one entity and then a character was actually quite genius, so I kept that structure. I just extended it a bit. So for instance, here I have my planet, so this is me. I am planet U and I'm orbiting something. So in order to get what I'm orbiting, because I'm still using a list here, that might be a bit strange, but as I'm orbiting one planet here, I just take the next one. So because it's a set, I will have an iterator and a next. So this is just to get the first element of that set. And then I will do the same for Santa, get the first element of that set. And I will run a function that I call orbit list, and that will return a string, which looks a little bit like the string down here, where you have the planet, and then the orbit with another planet, and the orbit with another planet, and so on. So the orbit list is a very simple function. We take the planet name, we see if we have any orbits on this planet, and then we add the orbit sign plus another orbit list of the first element of that planet set. And that is one thing that will be returned as a string. Then we will get this orbit list here. So I have two strings with orbit list. Those are what you see down here. Then what I do is that I go through this string. So I split this string in orbits. And I go through and look in my orbits list until I find something that is contained in the Santa orbit list. And I will increase the number here. So when I actually find one entity that is in the Santa orbit list, then I know they have converged. And then I will break and I have my first number. Then I will set up a second number j here and do the same thing with the Santa orbit list to my orbit list. And when they converge, I will have another number, and then I will just add those two together. So 253 was my number. Let's see if this is the correct number. It's the correct number. You get a gold star. I get a gold star. Everybody gets a gold star. We have solved day 6 of Advent of Code. I hope that you found this video interesting. I hope that you learned something. Maybe this was a little bit of a cheating that I actually did a very quick and dirty way to solve this, but sometimes you just need to figure out a way to solve a problem in as cheap as possible, so you can actually find something that you can prototype. And this is maybe not the most elegant way to solve this problem, but for this instant is a good way to implement it. And I do a lot of proof of concepts, so I'm very used to making something quick and dirty and then throwing it away if it doesn't work. And if it works, then we have something that we can throw away, but we learn something from it and we can go forward. If you haven't subscribed to this channel, I do a lot of these tutorials and try to inspire with new interesting projects, then please do that. Subscribe to the channel. If you like this video, give it a like, share it with your friends and colleagues. If you have any comments or suggestions or other solutions that you have in mind, please leave them down in the comment section down below. And I really hope to see you in the next video.